Hi, we are Trelawney's Crystal Ball, and together we're taking on Challenge 12. The problem: Jacobs wants to predict a financial hit to a project at least 2 months in advance of occurrence. Can we develop a machine learning model that can predict the probability of using historical project data? The benefits: the ability to spot potential issues earlier in a project's lifecycle unlocks the opportunity for Jacobs to put in place mitigations and steer the ship away from disaster.
I've called this meeting to try and understand why so many of our projects in this portfolio are taking hits each month, and I'm not getting any warnings from my team leads. Our client demand consistency and predictability, and will go elsewhere for services if we can't improve. Andrew, Martin, can you help me understand the issues on your projects?
Christine, I'm sorry. I find that by the time we get sight of emerging issues, that it's too late to raise early warnings or discuss mitigations with the team without there being some sort of financial impact. Our processes are just too slow to react and we need more time.
Sorry, Christine, I'm in a similar position to Andrew. My hands are tied. I can produce productivity curves and provide you with forecasts, but they aren't very reliable. The forecasts are only based on a basic interpretation of our productivity to date. They're too linear and inflexible.
I wish we had a crystal ball to predict when our projects are going to take hit months in advance.
So in a nutshell, the problem for Jacobs is to identify and predict when gross margin variance becomes a hit or a release. They need 2 months to identify and implement corrective actions. What questions do they have? How many projects are going to experience a hit? Who is accountable for the projects? What is the monetary impact of a hit or release? What are the key influences? KPIs. A league table of projects heading towards a hit or a release. Ranking of projects dependent on value as well as probability of pain. Maximize financial impact of avoiding a hit or release, and a heat map of key influences. What data have we got to work with? Jacobs provided financial data for 360 projects. Included in that data were user input performance scoring for a variety of disciplines and functions within each project. The data analyst work, we used tools that were for Python for cleaning the model data, Power BI to gain insights and provide visualizations from the model data. The packages that we used within Python were pandas for cleaning the data, and then for data modeling and predicting, we used scikit-learn, NumPy, and matplotlib. Here we have the two processes that we created. Cleaning the data reduced the redundant rows to ensure that the next stage of modeling the data did not contain extraneous variables. Modeling the data. We used various tools, as previously mentioned, to create a powerful prediction of whether the projects will be a hit or release within a Gaussian neural network. From this, we identified that the accuracy of our model is 79%, which is a great building block for future modeling. We will use Power BI to provide powerful dashboards that enable the portfolio program managers to delve deeply into the data. The dashboard front page will provide a league table of projects that are at risk of being a hit in the next 2 months, weighted towards their project budget. Within this dashboard, we can see that there are a number of influences that our neural net has determined are the most likely to affect the project. The program manager can hover over various items and gain insights into the project journey so far, and finding out reasons for variance. By hovering over the hit risk, we can see what the variance over time is for that particular project. And by hovering over the heat map in various areas, text fields will pop up where users have added commentary and narrative to their inputs for red, amber, greens. The commercial application and benefits for Jacobs. Jacobs will use this tool to confidently forecast hits and releases months in advance, focusing on the projects most at risk. Project managers can put in place timely targeted interventions in the projects at risk. Project hits will often align with missing client KPIs on consistency and predictability. This tool will shape clients' perception of Jacobs and their value as dependable and predictable partner. Predictability and consistency will unlock billions in future work for Jacobs. Project costs will be reduced by avoiding expensive interventions required by the time project difficulties become deeply entrenched. Earlier action attracts less project debt, benefiting Jacobs and their clients. Jacobs' new powers of divination can be commercialized directly, offering their crystal ball services to partners and end clients alike. The machine learning will improve continuously with more data, learning on contract data from earlier in the project lifecycle, and grow into a powerful and accurate predictive tool. Future developments for Project Hack 8. More machine learning to improve the accuracy of results. Develop a working front page league table identifying high probability projects. Jacobs to request narratives for user input so that they can be queried from the dashboard as floating fields. Develop a heat map in Power BI to identify reasons for high probability projects. and focus on releases as well as hits because these are just as important.
One of the projecting success experts helped us with a feature importance technique that assigns a score to input features based on how useful they are at predicting a target variable. In our case, we use this to look at the financial features of each project and how they influence the target variable, GM variance. We identified that US dollar base transaction price, US dollar estimated to complete, project to date gross margin percentage are the most significant attributes of whether it would be a hit or release. In terms of the time element series, we weren't able to do this due to time constraints. However, we have the foundations of a model that could be added so that we can predict hits or releases over time. We just need more timed phase data. We could go back to the data holder to target the needed data. Having the data over a longer time period, it would be so much more helpful due to we'd be able to do a lot more accurate time forecasting. Without this, we decided that there was insufficient accuracy in the model to confidently prove if a project in 2 months would be a hit or release.